Let's discuss the microphone in much more detail. A microphone is defined as a transducer or energy converter that converts sound into an electrical signal, which may then be amplified, transmitted, or recorded. For announcers, this is the instrument that plays back your voice on the air and is more commonly called the mic. There are four main types of microphones: dynamic, condenser, ribbon, and USB. With the dynamic microphone, the audio signal is generated by moving a coil within a magnetic field, in other words, via electromagnetism. These microphones have relatively simple construction. They're sturdy, able to take a beating, are reliable, and versatile. However, they are less sensitive to sound pressure levels, high frequencies, and humidity. They can be used at rather high gain or volume before producing feedback, which is the high squealing sound that can come through speakers. Dynamic mics are most often used in radio stations or for live sound reproduction, like PA or public address systems and live concerts. They do not require an external power source and are generally less expensive than condenser and ribbon mics. Condenser microphones work like a capacitor where sound pressure vibrates a diaphragm toward a fixed metal plate, creating an electrical charge to produce an audio signal. These microphones offer superior sound quality and have the widest audible frequency response. Condensers aren't as sturdy as dynamic microphones, and they are vulnerable to structural vibration and humidity. These mics are the best choice for high fidelity studio recordings and high end broadcast studios. They do require an external power supply, internal batteries, or phantom power provided by the mixer or console, and are generally the most expensive microphone options. A ribbon microphone utilizes electromagnetism similar to a dynamic microphone, but instead of using a diaphragm, it uses a thin metal ribbon to pick up air velocity, not just air displacement or sound pressure. These were commonly used in the golden age of radio. They are very fragile and sensitive to humidity. Ribbon mics are not as responsive to higher frequencies, but they do retain a warm, vintage sound and they do not require an external power source. The design of a USB microphone contains similar elements of traditional condenser or dynamic microphones. They also include a built in preamp, which eliminates the need to be connected to a mixer or external preamp, along with a built in analog to digital converter that changes the output from analog voltage to digital data so it can be plugged directly into a computer. USB microphones are commonly used for mobile digital recording and in podcast studio locations. Here are pictures of common Electrovoice RE20 dynamic mic, an expensive Neumann TLM 103 condenser microphone, a vintage RCA Type 77D mic, and a popular Blue Yeti USB microphone. Now let's talk about a microphone's pickup pattern, known as its polarity pattern or directionality. This is the three-dimensional space surrounding a microphone where it is most sensitive to sound. The five microphone polarity patterns are omnidirectional, bidirectional or figure eight, unidirectional or cardioid, super or hypercardioid, and lobar or shotgun patterns. As you look at the diagrams on the slides, remember you are looking down at the pattern as if the microphone was pointing toward the middle of the spheres from the top. An omnidirectional pattern shows that the microphone is equally sensitive to sound from all directions no matter where the microphone is positioned. These patterns are often used for orchestra recordings or when room ambiance is desired. The bidirectional or figure eight pattern is sensitive to sound coming from the front and rear, but rejects sound coming from the sides. This is the common pattern for ribbon microphones and is used for variations on stereo recordings or for two-person, one microphone applications. The unidirectional or cardioid pattern is most often used in broadcast and recording studios and on stage. It is most sensitive to sound coming from the front. Sound from the sides is picked up quieter, and sound from the rear is significantly rejected. This is the common pattern for dynamic, condenser, and USB microphones. The super or hypercardioid pattern falls in between the cardioid and figure eight patterns. It is more focused on sound from the front, but sound from the rear is not as suppressed as much. This pattern is useful for some live audio situations, like when used to microphone a drum kit. The low bar or shotgun pattern is the most highly directional pattern, meaning it has a very narrow lobe to sound from the front, small lobes of sensitivity to the left, right, and rear, but significantly less than other directional microphones. Shotgun patterns are commonly used on TV and film sets with sportscasters in stadiums or arenas and for field recordings. Here is a three-dimensional image of the cardioid pattern with a Shure SM58 stage microphone. If you are using this microphone, you can see that you would need to be speaking toward the front of it for the best sound. Your voice level will diminish as you move to the sides and will almost disappear completely if you speak toward the back of the mic. Some studio standard accessories that accompany the microphones are a boom, shock mount, windscreen or pop filter, and a preamp or processor. The mic boom is an extendable and adjustable arm that allows the mic to be positioned without holding it to the proper placement for the pickup pattern to be most effective. A shock mount is the suspension device that uses elastic or rubber bands to partially isolate and protect the microphone from vibrations spread through the boom or tabletop. A windscreen or pop filter is a noise protection accessory that reduces or eliminates popping sounds. They prevent strong blasts of air from clipping or distorting the sound. The preamp is the sound engineering device that prepares a microphone signal to be processed by other equipment. Mic signals are often too weak to be transmitted to mixing consoles and recording devices with adequate quality. Preamps increase a microphone signal to line level, which is the level of strength required by such devices, and are often combined with a processor, which adds compression, equalization, and enhancement capabilities. Because most listeners are listening to the radio in a car or with something else in the background, low rumbling frequencies like traffic or road noise, airplanes, heaters, or air conditioners compete with the radio. Many stations utilize their mic processor with a low end roll off, which helps an announcer's voice get above the competing low rumbling frequencies so they are clear and understandable, especially used in news and talk formats like NPR.